10th Physical Science Lesson Classification of Elements. Topic Electron Affinity. It is called electron gain enthalpy. Next topic Electronegativity. Electronegativity. First, electron affinity. When an electron is added to its neutral gaseous atom, then liberating the energy is called electron affinity and also called electron gain enthalpy. So here example, oxygen atom is there, atomic number 8, electron configuration 1s2, 2s2, 2p4. This oxygen atom and gained 2 electrons from another element, so then some energy is released from this oxygen atom. So here M is a element, and here when gained electron from another atom, so here some energy is released. When first electron gained, so then the energy is released as a E1. Second electron gained from another element, then second energy is released from the atom. So after getting 2 electrons, oxygen liberated E1 energy and E2 energy. So this is called electron gain enthalpy or electron affinity. When we see the group wise, fluorine, chlorine, bromine, iodine, so this electron gain enthalpy or electron affinity decreases. When we see the period wise, sodium, magnesium, aluminum, silicon, so this electron affinity decreases. Next one, electronegativity. The relative tendency of its atom to attract electrons toward itself when it is bonded to the atom of another element. So here is example. Carbon is there. Carbon reacted with the oxygen and formed the carbon dioxide compound. So here between the carbon and one oxygen, 4 electrons are there, and right side also 4 electrons are there between carbon and oxygen. So here the elements are not donated the electrons to another element. All electrons are reached between the 2 elements. So the both elements are shared these electrons. So carbon used these electrons and oxygen used these electrons. So here also carbon and oxygen, both of them are used these 4 electrons. So these electrons are called shared electrons. Why? Because carbon shared and oxygen also shared these electrons. So these electrons are called shared electrons. Okay. So Mulliken stated that electronegativity of an element is the average value of its ionization energy and electron affinity. So the electronegativity is ionization energy plus electron affinity by 2. So this is a average value of ionization energy and electron affinity. Next, Pauling says that assign the electronegativity values for elements on the basis of their bond energies. So here we see the bond formed between the two elements. So the elements negativity values are on the basis of their bond energies. Electronegativity values of elements decrease as we go down in a group as atomic radius is increased. So always we know group wise the atomic radius are increased. So cells are added to element to another element. So when the cells are improved, automatically the atomic radius is increased. So here we can see the electronegativity values of elements are decreased as we go down in a group. In a periodic wise, so when we see the periodic wise, how is the atoms of the elements? So the atomic radius is decreased. Okay, so the electronegativity is increases along period from left to right. Why? Because atomic radius is decreased here. Next one, metallic and non-metallic properties. So third period elements are taken here: sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine. Here sodium and magnesium metals, sodium, magnesium and metals, aluminum and silicon metalloids, aluminum, silicon metalloids means semi metals, and PS and chlorine non-metals, PS and chlorine non-metals. So when we observe all these metals, so metallic characters decrease and non-metallic characters increases as we move along a period from left to right side. So sodium to chlorine we observe metallic characters are decreased and non-metallic properties are increased. And we see the group wise: carbon, silicon, germanium, strontium, lead. So here carbon is a non-metal, silicon, germanium metalloids, strontium and lead metals. So metallic character increases while non-metallic character decreases in a group as we move from top to bottom. So here we will see first non-metals, next semi-metals, next metals. So metals are increased here top to bottom. So when we see all the properties of elements, they shows trend in groups and periods. First one, valency. So in groups, how is the valency means same for all elements, and we see the periods 1 to 4 increases and decreases to 0. Atomic radius in group increases, decreases in periods. Ionization energy decreases in groups and increases in periods. Electron affinity decreases in groups, increases in periods. Electronegativity decreases in groups, increases in periods. Electropositivity increases in groups, decreases in periods. Metallic nature. Metallic nature increases in groups, decreases in periods. Non-metallic character decreases in groups, increases in periods. So all these are known in the periodic property as a trends in groups and periods.